So in this video, we're going to take a look at how we can apply geometric sequences to financial math questions. So if we are increasing something by a given percentage, just like you would with an interest rate, supposing that interest rate is 2% per year, well, we would say that the equivalent in terms of our formula you can see in front of you, I is going to be 0.02, right? Okay, so if it was 5%, it would be 0.05. Now, if I'm talking per year, then it's very easy, right? Because it just means n again is that number of years. But if I am compounding in a different way, like through months or in quarters, then I need to adjust the number of periods that I compound, and I'll be looking at examples through this video as to how to do that. So this setup that you can see in front of you in this blue box is almost identical to the previous work we took a look at when things were increasing and decreasing in those sort of decay and growth problems. All right, so let's jump in, do some examples, and you're going to see exactly how this works. And I'm going to explain that formula as we go along. It's going to help us with all of these questions. Now, there is a way of doing this on the Finance app on your calculators too, so do check out my video on that as well. Right, we've got $5,000 invested for 4 years at 7% per year, and we are compounding that annually. All right, so let's jump in. Now, you can see that U0 is the initial investment, and clearly that is $5,000. Now, how many compounding periods do we have? Well, it's compounded every year, and the interest rate is per year as well. So this makes it nice and simple. We've got over 4 years. That means n is going to be 4. And if we've got a 7% interest rate, then I is 0.07. So all we have to do is pop these numbers into the formula, and it's going to work out our answer to A, because we're looking to find out how much money there is at the end of these 4 years. So we're going to have 5,000 multiplied by 1.07 to the power of 4, and that is rounded to 2 decimal places, 6,553.98. All right, and we're in dollars there, so that's how much we've got. Now, part B, how much interest has been earned? Well, we need to start with that amount that we've got at the end and take away the initial investment. So that will be the difference between the two, and that is going to be $1,553.98. Let's move on and try a more complex question. So this is similar. We've got some similar numbers going on here. We've got $5,000 invested for 4 years. It's 3% interest rate per year. The PA stands for per annum, per year. But this time we're compounding it and adding on that interest every quarter, right? Every 3 months. So that's going to make some significant adjustments to this calculation. Now, to start with, U0 is still 5,000, so we've got no problem there. The number of compounding periods, well, it's 4 years, and every year it gets compounded quarterly, so 4 times. So that's going to mean that we've got 16 compounding periods. So n, in this case, is 16. Now, we have to be very careful with I at this point, because I is the interest rate per compounding period. Now, if we have 3% per year, then to work out what it is per compounding period, well, we're going to have to divide it by 4 if there's 4 compounding periods in a year. So this is 0.75%. Okay, so that is our interest rate per quarter, and that's going to help us calculate this. So it's a little bit like having an equivalent decimal of 0.0075, right? Okay, now let's pop all this into that formula then and see what happens. So we're going to have 5,000 multiplied by 1.0075 to the power of 16. Now, if we work that out on the calculator, we're going to have 5634.96. And there is our answer. Okay, so now we've managed to work out what this is like when we have an adjustment and the compounding period is not the same as the number of years. Let's see if we can make this even more challenging now and work this one backwards. So we've got a question. How much does Ivana need to invest now to get a maturing value of $10,000 in 4 years' time. We've got some information there about interest rates and how much it's compounded. So this time, UN is given to us. We know what we're going to come out with. We're going to come out with 10,000. We're trying to establish what is the amount we put in, right? So we don't yet know what U0 is. Now, the number of compounding periods, well, we've got 4 years and we compound it twice every year. So we're going to have to work out 4 times 2, which is 8. So that is going to be our number of compounding periods, N. So we've got 8 of them. Now, let's just think about the interest rate per compounding period. It's 8% per year, but we have 2 compounding periods per year. So we need to divide that 8% by 2. So it's going to be 4% per compounding year. So therefore, I is going to be 0.04. Right, now we can put all this information into our formula and see what happens. So 10,000 is equal to U0 times 1.04 to the power of 8. Now, if we just divide through by 1.04 to the power of 8, we're going to have our solution, aren't we? We've got 10,000 divided by 1.04 to the power of 8. That is going to give us our U0. And if we work out that calculation, we're going to have U0 is $7,307. Do check you get the same answer as me. Okay, so that's one way you have to work backwards. Let's just keep adding those layers of complexity into these calculations. Okay, it really will help you try and do these questions before I've done them. So pause that video and have a go yourself first. So in this one, we've got a painting that is currently worth $5,000. Monthly deposits are made into an investment account so she can purchase the painting in 3 years' time. If inflation averages 2.5% per year, calculate the value of the painting indexed for inflation for 3 years. Now, there's lots of information here, and it's that may or may not be useful. So let's go through this very slowly and make sure we understand exactly what it is we're trying to find. So we've got this measure of inflation per year, right? We've got to calculate the value of the painting indexed for inflation after 3 years. So really, we're only thinking about the inflation and not a lot else. So U0 clearly is 5,000. If we are looking at inflation and it's per year, and we've got 3 years, well, N is clearly just 3. And it makes it nice and easy with R as well, that means, because, again, we don't have to worry about dividing through by anything. R is going to be let's use the correct terminology. Let's use I. I is going to be 0.025. So all we've got to do then is just to work out what it's worth in 3 years' time is have 5,000 multiplied by 1.025 to the power of 3. And that's going to be 5,384.45. And look, that's all we have to do. There's nothing else to worry about in that particular question. All right, let's try another one. So what about this? We have got Gemma. She invests 4,000 into an account for 5 years. So straight away, let's start writing things down. We've got 4,000 as U0. Now, we've got 5 years, and it's compounded half yearly. So 5 times 2 is 10. So this is telling us that the number of compounding periods we have to consider is 10, and is 10. In terms of the interest rate per compounding period, well, we have that the interest rate per year is 4.8%. But we're going to need to divide that by 2 because it gets compounded twice in a year. So that every compounding period, it increases by 2.4%. So this means that I is equal to 0.024. So in part A, we've got to calculate the value of the investment after 5 years. Let's just run through this. We have got 4,000 multiplied by 1.024 to the power of 10. And this comes out at 5,070.60. And we are in dollars here. Now, part B is quite interesting because we're talking about inflation now, right? So it's telling us that the inflation over the period actually averaged 3%. And that's per year. Find the real value of the investment if we index this for inflation. So what that's asking is, what is the 4,000 actually worth if we think about the inflation that's going to happen? So to do this, let's think about this, right? That answer, that real value that it's worth, well, if we multiply it by 1.03, and that is with our inflation being at 3%, so you can see where that 1.03 is coming from, but to the power of 5 for 5 years, we know that that is going to come out at our answer from part A. So all we have to do is work backwards to see if we can find out what that is. It's going to be 5070.60 divided by 1.03 to the power of 5, and if we work that out, that investment is actually worth $4,373.94. There we go. Okay, now then, let's keep moving. Final question. Let's see if we can have a quick go at these ones. These are depreciation. Nice and simple questions, but just a little different because we're going to be going down. So an industrial dishwasher was purchased for £2,400. Already, I'm going to write down that U0 equals 2,400. Now it depreciates, so goes down by 15% each year. So if you wanted to think about it in terms of I, it's going to be negative 0.15 because it's going down. If you don't need to worry about that particularly though, because what we can just say, and you probably jump straight to this, is it's going to be 2,400 multiplied by 0.85 to the power of 6. I haven't worried about compounding periods because it's just per year, right? So it's going to be the same as the number of years. So if we work that out, we are going to have approximately 905.16. That is our answer to part A. By how much did it depreciate? Well, I take that original amount, I take away what it's worth now, and I'm going to see the difference. That's our depreciation. That is going to be 1,494.84. And we are done. So I hope that this video helped you to understand how we can use those formulas to calculate these financial questions.